Good evening, everyone. Welcome to Skillza Deep Learning Sessions. We'll start the session under 2 minutes. So we'll start the session soon.
Sure, Chandra. Good evening, all. So let me share my presentation quickly. So this is week 3, day 4. So I just want to combine both the topics, ANN and CNN. Probably today we will complete all the concepts. The remaining concepts we will discuss tomorrow. Are you people able to see my screen? Can anyone confirm?
Yes, sir. It's visible.
Okay, thank you. So before going to ANN, do you people have any doubts in yesterday's session? Activations, where to use which activation, all the things. So yesterday we already discussed a few concepts of ANN, but let me repeat again quickly. So ANN is the very simple network, and it learns as we discussed earlier. So we have one input to one output and few hidden layers, but the only thing we have to add here is we have to discuss the feedback network as well. So means what is feedback here? We see here our inputs will be here, right? And we will get our output here. But between these two, we have hidden layers, and the data will be transferred from this point, means from input layer to hidden layers, and the data will feed forward and it will reach to the output layer. So during this process, all the weight, depending on the existing weights, the outputs will be calculated at each and every node, and we will get one output. So depending on the output, we will send one feedback signal to the input section. Okay, during this feedback signal, depending on the feedback signal, the network try to optimize the values depending on the optimizer we use. So yesterday we discussed Adam optimizer, right? So we will discuss what are the remaining optimizers we have and remaining all the things. So before that, try to understand ANN is a simple network, and here we have to use input output layers along with few hidden layers. At least we have to use one hidden layer. Okay. So one more thing is we have to use one feedback signal. Any doubt here? Yesterday I have already discussed. So one more thing, which is very interesting one we can play here is this playground.tensorflow.org. So you people can play here. Let me quickly open this. How can we open this? We can directly copy paste this link, and what we can do. Let me quickly drag. Are you people able to see my screen here? So it's very simple one. You can just copy paste this playground.tensorflow.org into your browser, and you can click and you will get this environment. So this is very interactive environment. Here we can set all the things and we can see how the networks are working. Okay, we can compare all the performances of networks with respect to different data sets as well. So here you will get all the things. See here, let me explain one by one. So here we have buttons. If you want, you know what is epoch, right? So if you want to go by epoch, you can use this button. If you want to continuously train your model, you can use this button. Okay, here you will see how many epochs are there, means what is the current epoch number. And here you can see what is the learning rate, what is the activation we have to use, whether yesterday I discussed, right? We have so many activation. We can use ReLU, TANH, sigmoids, linear, all the things here. So we can select the respective activation, and we can see the regularization value either L1 or L2, and we can set the rate value here, and we can set the problem statement here, whether we are going for classification or regression. Any doubt here? No, right? We have to set all the parameters before running the model. Okay. After that, here you can see different data set types. Data sets means here you can select, here you can see some data set, right? So like that, you can select this one. Here you can see two different classes, but one area of class is like this, another area of class is like this. So we can select simple, very simple kind of network here. So here it is very simple, right? All the blue points are one side, all the orange points are one side. So we can simply drag a line and we can simply classify this data. Okay. Moreover, we can go for very complex data types. Here you can see, if you want to classify this data, we have to separate all this area into one group and all this area into one group. Any doubt here? How to select data? So here we have 4 different data types. We can select the required data type. Not only the selection, we can separate the test train data values here. Here it is 50-50. We can change it to 70-30 or 80-20. You can change it to any value. Moreover, you can add the noise. Here it is very clear, right? Clearly it's if you see here or here, the shapes are very clear. So we can easily identify what is this line. Okay. So if you want to add some noise, you can add some noise here. You can see the data is changing when I'm adding some noise here. Okay. So like that, you can add noise, you can increase the batch size as well. So you can do all the things here. Okay. If you want to generate new test set, you can set all the values and you can regenerate and you can use here. Any doubt here? One more thing here, you can here we have two testers, right? One is sorry, inputs x1 and x2. Okay, along with these two, you can add x1 square, x2 square, x1, x2, sign up x1, sign up x2. Like that, we have seven input features here. So you can add any number of, not any number, you can add at least two, or you can increase to 7. Okay, you can, I think you can disable this part as well. So you can use at least one feature and you can increase as well. Any doubt here? After that, here we have two hidden layers. So if you want to add more hidden layers, you can click here and you will get one more hidden layer here. Okay, if you want to delete hidden layers, you can directly click here. It's kind of programming only, but instead of going for programming and complex lines of code to visualize all the things, we are just playing here with the TensorFlow GUI. Any doubt here? No, right? So here again, after not only we can add or delete layers here in and also within the layer we can add number of neurons. So if you want to add, here we have two layers, right? So if you want to use only one layer, so here we have only one layer. So inside this layer also, if you want to increase the number of neurons, we can increase. If you want to decrease the number of neurons, we can decrease. So now you understand, right, how to add layers and how to increase or decrease layers, all the things, right? So this is your output. So now if you want to train your model, okay, now I have selected this data and sorry, so there is no noise, batch size is 10, and here you can see I'm using only two features and 4 neurons in first hidden layer and 2 neurons in second hidden layer. This is my output layer. Okay, now let me run for one epoch here. You can see something here. So this is the, here you can see 2 points. One is the test loss, another one is the training loss. So you can see all the values, whether the loss is increasing or decreasing, we can check. So after one epoch, this is the loss, means loss is reducing. You can see when I'm running in epoch and epoch. See here, my loss is almost reduced to 0.1. Okay, and this is the classification. So this is the line, this is the knowledge of the model. You can see the classification here, right? So we are classifying this entire area into one group and this entire area into one group. When I'm training for more iterations, you can see my accuracy or my test loss is continuously reducing, means my accuracy is increasing. Okay, but after if we see what will happen after few epochs, see it is reduced to 0.0007, 0.005, 0.004, after 47, 0.003. Okay, now if I am, yesterday I discussed, right, the importance of number of epochs. Okay, if you increase the number of epochs, it will increase the training time. Okay, but after certain point, it won't be able to increase the accuracy. See here my training loss is 0.002, right? So here within 60 epochs, I am able to reach that point. If I'm continuously increasing the epochs, you can see I'm increasing here, but after this point, I am unable to reduce anymore. So here it is 100% okay. I will check in another data set. It's a very simple data set, right? So let me repeat this process with another data set. Okay, select this data set and now check how the data is varying. See here my loss is 0.001, right? So even after increasing the number of epochs, I am not able to reduce. Okay, here also it's coming to 0. See, this is very interesting one. Here you can see how network is. Here it requires huge number of epochs, but not only the epochs. See here, my error is not reducing, means my accuracy is not increasing anymore. Okay, it is stabilized at 0.287, means 0.2 or 0.3, around 0.3, means this network is not Here you can see one network, right? So this is one network, and this network is not suitable for this kind of problem. So here, see, my epochs are increasing continuously and I reach 2.5K, but still I am unable to reduce this error. And you can see the classification. I'm classifying like this. Is it the good classification? You can see some, what is orange points inside the blue area, right? So this is not the good one. So in this case, what we have to do? First, we have to increase the number of epochs, but even after increasing the number of epochs also, I am unable to classify this environment into proper areas, right? Or proper segments. So here I have to change my network. Let's see how it will work if I increase number of nodes here and here. Okay. And now again, try to train it. See, now what happened when I'm increasing these nodes here, I'm clearly able to classify the solution space into two parts, right? And the classification also very good here. Now you can understand, I think, how to classify or how to increase your accuracy. Previously, this is your network, right? Okay, when we're having only these nodes here. Okay, now it is working. Let me reduce one more node here. Still it is reducing. You have to concentrate on this value, whether we are able to classify or not. So if it is reducing, okay, but see here, it's taking very huge number of epochs, right? So this is not good. See here, you can see some noise. Means this noise is due to the optimizer. So we are not using the proper optimizer here. So we have to change the optimizer here. It's continuously varying, right? It's not stabilized one. So your network is providing this kind of results, means your optimizer is not good and your optimizer is continuously trying to change the weight, and that is causing some turbulence here. Okay, we have to change this process. And if we add one more node here, and you can see, this is a very interesting one. This is very simple network. Previously I have used for example, I think 6 neurons here and 4 neurons here, right? Then I got this result. But here, even though using 5 neurons in 2 layers, I am able to reach this accuracy. Okay, here we have to trade off between these two, whether we have to go for more epochs or more number of neurons. But in real time, we have to we can spend some time on training, but we have to concentrate on complexity of the network. We have to reduce the network complexity, then only we can incorporate this into real-time systems. Any doubt here? The problem is, even after we are adding more number of neurons here and here, see, okay, we can easily get this value within 100 number of epochs or 50 number of epochs. Okay, but the problem is the complexity here is very high. Any doubt? Now let me take another data set here, and okay, this is somewhat complex data set, right? So try to concentrate on here and see how our network is able to. So here I'm using only one layer with three neurons, and here you can see my accuracy is not increasing at all. It is stabilized at 0.45. Any doubt here? No, right? So now let's try to increase the number of neurons in one network. Sorry, one layer. Still we are seeing the same kind of performance here. It's trying to classify, but still struggling, right? See, the loss is stabilized. Okay, it means we have to change the architecture. Add one more layer here and now try to check. Check, are we able to reduce this loss or not? Here you can see this network. In this particular network, you can see two parameters, right? One is the test loss, another one is the training loss. So here you can see some difference. Here the training loss is somewhat low, but test loss is high. Means we have some overfitting issue here. Okay, we have to change this logic. This is not a good one. So we have to concentrate on all these parameters, whether these two are at same line or not. If these two are not on the same line, means your test loss and training loss are both not on the same line, and your training loss is lower side and your testing loss is on upper side, means your network is trying to optimize the or trying to fit the training data. Means while training it's okay, but while testing it's failing, means there is some issue, maybe underfitting or overfitting. So we have to go back to your data and we have to check, is there any issues, or what is the whether the data is balanced or not, or complete or not, what is the size of data. So here we have to try to increase the data samples. Like that we have to change our data. Okay, so here it is standard one, right? So let me take another layer here and check whether are we able to classify this or not. Let me add to one more node here and see. So try to concentrate here whether it is reducing or not. See, here we are able to classify this, but there is some noise. But check the values whether this noise is reducing or not continuously. See here, it is reduced till this point, but still it is struggling, and it has taken more than 1.5K iterations. Now it is stabilized, but it's not the good one, right? So now try to concentrate on adding one more feature here. Okay, let me add two more features, x1 square and x2 square here. Now let me run this one. It is working, but so much of variations here, right? The variation level is very high. So this is not the good one. So you can add one more neuron here, and you can add one more input feature here and try again. One more thing here, within these nodes also you can see what is the nature of each and every node. Okay, this node is trying to concentrate on this area, and this node is trying to concentrate on this area. This node is trying to concentrate on this area. So you can see the areas of concentration. So it almost reached 0.1, but the test loss is still high, right? So let me add one more node here, and again, it's the trial and error method. We don't know which network provide high accuracy, which network provide very low accuracy. You can see here, we are almost able to classify this network. See, all the blue lines are on blue side and all the orange lines are on orange side. Any doubt here? But here again, you can see some overfitting here. Are you people able to understand what is overfitting here? So here we are trying to connect all the blue dots with blue lines, but the problem is we are not classifying in problem. If we see here whether this is this the good one? Here you can see my cursor, right? Here this should be orange area, right? But it is showing this as blue area. Means here, apart from the this measurement values, we can see some problems here. Okay, that's why during training the training loss is 0, but during testing we have some loss here. Means this network is good at training, but we are seeing some problem in the test due to this overfitting problems. This is the overfitting. Okay, if you want to reduce this overfitting, what we have to do? We have to add some noise here. Okay, when we are adding some noise, again it will cause or it will incorporate some problems. But here consider one more thing. Noise is good for model when the model is struggling with overfitting or underfitting. Okay, in other case noise will cause another issues. What is the noise in dataset? Previously we discussed, right? Different concepts like anomaly detection. In anomaly detection concepts we discussed what is noise and what will happen when we use this anomaly in the groups, right? During classification or clustering in unsupervised machine learning concepts. So the same thing here. When we have overfitting, then this noise will help us to avoid that problem. Okay, but in other cases we have to avoid the noise or we have to filter out the noise. So see here, now you can see some what we can say, some similarity between test loss and train loss. Previously the training loss is 0, right? And test loss is 0.0 something. Now both are same, both are at the same value. Means our model is good, but it is unable to identify or unable to classify the data. So now the data is good, we have to change the model. You understand, right? How to change data as well as model, when to change data or when to change model architecture. Okay, here let me add 2 more input features and let me run it. Let's see what will happen here. We are using all the 7 features. Let me add few more nodes here and here. And see again here we have some variations. Still we are able to stabilize as well as reduce the error, right? So let's wait. Okay, let me remove all the confusing features here and again let me run this one. Let's see what will happen. Okay, actually it's taking huge amount of time. We already crossed 30 minutes, but the thing is you can directly log into this page and you can no need of any credentials. You can directly use this page and you can play. If you have any doubts, you can let me know. Any doubts here? Only thing is we have to change all the, what we can say, all the activations, and we have to check what is happening. whether both are reducing or not. We have to concentrate here, we have to concentrate here on noise part, and we have to concentrate on here, as well as we have to check here as well. Okay, how many number of epochs is taking and what kind of problem we are using. If you want to go for regression, you can select the regression as well, and here you can see some points, and you can train your model, and you can check the values as well. So you can directly select, and you can directly provide whether it is able to get means whether it is able to get the exact value or not. You can see here it's a regression problem, right? It's not classification. We have to identify the value. Any doubt here? So previously in last session, in last lab session, you people asked me, right? Sir, I'm getting this much amount of error, and I'm getting only 60% or 65%. How to handle this issue? Whether we have to stop here or whether we have to proceed further and optimize further, right? So this is the different. These are the different ways we have to optimize model as well as to change the data type. Here change in the data means we are not changing entire data set, but we are filtering data or we are adding data to the existing data. If the data is very less, then we can add some more samples, means we can collect a few more samples and we can add those samples to the existing data. Okay, if data has some anomalies, we can filter out all the anomalies. So like that, we can go for some pre-processing. Do people have any doubt here? So to understand all those things and to understand effect of each and every terminology or each and every concept, here we have concept of learning rate, activation, what will happen when we use ReLU, what will happen when we use TANH, like that. We have different concepts here, right? So we can concentrate on all these things and we can try all the things and we can understand what will happen when we increase features or when we reduce features, or when we increase on neurons and when we decrease layers, all the things. Any doubt in this space? This is very helpful one, particularly for the people who are at the learning stage. Now you people are at the stage, right? So you can play as much as you can, and well, don't see this as a playground. It is very useful ground where we can learn all the basics of neural networks. The fundamentals are all these things, right? Features, data, noise, layers, neurons, activations, learning rate, all these things, right? So you can understand all these things. Any doubt in this space? Otherwise, I will go back to my presentation. If you have any doubt, you can directly post in the chat box. Okay, I think you people don't have any doubts. So let me go back to my presentation and continue with the. So clear, right? You can note down this URL. It's a very simple one. You can directly search for playground, TensorFlow playground in internet, and you will get this page. Okay. The next one is back propagation. As I mentioned earlier, in ANN, we have to concentrate on both feed forward data as well as the back propagation. So here feed forward means we have to pass the signals from input layer to output layer through hidden layers. This is nothing but you are passing your data through these layers. At the same time, after getting the results, we have to send the error signal back to your input section. Okay. Now, yesterday we already discussed, but let me quickly explain one by one. So we have to compile, or we have to set the compilation options. Which kind of optimizer we have to use? What is optimizer here? Here we are getting some error signal, right? Depending on this error signal, we have to change the values. For example, here let's say here we have this weight wx. Okay, I'm writing here and it's getting there. Okay, here we have this wx, so its previous value is, let's say it is some 0.3. Okay, when it is 0.3, I'm getting good output, means we have to keep this 0.3 here. But when it is 0.3, my classification is wrong. Instead of getting y1, I am getting this when I'm sending this signal x1, or when I am sending a dog image, it is classifying as a cat, means I have to change this, right? It is not the good weight here, sorry. So here 0.3, right? So 0.3 is not the good weight, so I have to change this 0.3 here. So how can I change this 0.3? Not only this particular weight, I have weights at each and every point, right? And I have bias values at each and every neuron. Okay, I have to change all the weights as well as all the bias values. So to change those bias and weight values, we have to use one methodology, right? That methodology is known as optimizer. So we have some predefined, well-established methodologies like ADAM or SGD. Okay, so we can directly use, and loss means we have to calculate loss, right? Loss is nothing but how much amount of loss is here by comparing these result values or accuracy set output nodes. And we can use metrics, which kind of metrics we have to use, and loss weight, sample weight, mode weight metrics, and target sensor. So you can add all these metrics here, as well as once we have the compiled modeler, or once we have all the compilation options set, we can go for model training using fit method, right? This one yesterday we discussed this model.fit one. Okay, we can directly use here, and you can directly set your input and output. Along with these two, we have to set epoch and batch size. We already discussed, right? What is epoch and what is batch size. So these are the few code snippets. So here you can either, if you want to download from Keras, here I'm going with Keras framework. So if you want to proceed with PyTorch, you can has the same kind of lines in PyTorch as well. So you can download from PyTorch and you can use it. So here you can see all these things are in Keras. So losses are there, optimizers are there, metrics are there. Otherwise, you can directly mention the value like this. So loss is equal to mean squared error, MSE, you know, right? What is mean square error? And you can set the optimizer SGD. Okay, you can set the metrics, which kind of metrics you have to use, whether categorical accuracy or categorical cross entropy. We have different options. So same thing, we can go for if you want to go with sklearn, you can use the sklearn, and you can import all the metrics as well, and you can use the same thing. Now let me quickly go through what are the different types of losses we have. Here we are using MSE, right? So like that, we have different losses in Keras. We can directly import that, and we can directly provide that value. See, mean squared error, mean absolute error, like that. We have categorical cross entropy, okay, and Poisson error. We have different matrix, sorry, different kinds of losses. Okay, if you want to check what is the meaning of each and every one, you can directly go through internet and you can check. Okay, but in general, we use, when we are going for classification problem, we generally use categorical cross entropy. Okay, any doubt here? In regression, you can go with the mean square error, MSE. Do people have any doubt? So next one is the optimizer. Which optimizer is better? Optimizer is nothing but you have to change the weight, right? So this is more of calculation. We have equations for each and every optimizer, and we have so many, so much of research is there. You can go through the research articles and you can compare which one is better. But in general, we use this SGD, okay, gradient descent. Otherwise, we the best one is the ADAM. So if you want to compare which one is better, you can check here. Otherwise, you can go through the research. See here, here it is. F1 score means accuracy, kind of accuracy, right? So here it is training loss. So in all the optimizers, we are able to reduce the loss, and in all the optimizers, I am able to increase the accuracy. But see, in some cases, if you see here, something is increasing very slowly and something is increasing very fastly. If you see here, this is the best one, right? Adam is the best one. Okay, to reduce the loss, which is the best one? This is the best one. Which one? AdaGuard Optimizer. You can check here the name. Okay, AdaGuard. So you can check the colors here and you can check which one is the better one. And again, if we want to go with some specific application, you can check which is the best one depending using trial and error method. Again, you can use SGD ones and you can use Adam ones, and you can check which is providing better accuracies in quick timings. Again, along with the name, we can set some parameters. What is the learning rate? What is the momentum? All the things we can set. Okay, just try to understand. We have so many options here. I'm just explaining. We have so many options. Depending on your requirement, we have to select one. Okay, coming to matrix, as I explained earlier, we have this accuracy. We usually use this accuracy when we are going for regression, but when we are going for classification, we can use categorical accuracy. Okay, apart from these two, we have so many other options. Okay, when we are going for some different metrics or different algorithms like KNN, we can use K categorical metrics in K-means and all. But in general, we use accuracy and categorical accuracy. Any doubt here? So this is the program style we have. You can quickly check. We have to import all the things from Keras. Like all the things means we have to import the sequential network, means first we have to import the, what are the different steps? First we have to import the model. See, this is the one I'm talking about. First we have to import the model and we have to create an object for the model. After that we have to add layers. Which are layers we required, we can directly add one by one. Okay, after adding all the layers, we have to set compilation options, then we have to go for training. So 4 steps in model creation. First we have to create an object, then we have to add all the layers. After that we have to set compilation options. After that we have to go for training. So 4 steps. You can see create model, add layers, compile model, train model. So these 4 steps are very important. Before these 4 steps, we have some more steps like import all the things and process the data. You know, right, how to process data. If you have external data, we can directly load the data and we can go for pre-processing. Otherwise, we have another options as well. Means along with these layers, models, compilation, training objects or methods, we have data sets also. Okay, inside this Keras. So you can directly import the data set from the Keras. You can see here one statement, right? What is the statement here? From Keras.datasets import MNIST. Okay, this MNIST is nothing but your handwritten digits. So you can directly import the data and you can use it. But when we're importing this data, your data will be in the format of CSV, rows and columns. First, we have to convert that into images, then only we can use. Okay. Any doubt here? We'll see how can we convert that back into our data sets when we are dealing with CNN. But here we are directly use, if you want to go with ANN, we're not using any filters, right? So you can directly provide, we can directly take 784 nodes in the input and we can directly train our network. But we have to go for standard scaler. Otherwise here, see here, instead of using standard scaler, I am directly, this is image data, right? So what is the levels? How many levels up there? What is the maximum grayscale value? 255, right? So to fit the 255 levels in 0 and 1 range, we can directly divide this value with 255. I discussed yesterday, right? How to fit data between -1 and 1. So here also same thing, we can directly divide because we know the maximum value, right? So we can divide all the pixels or values of all the pixels with the 255. We will get the values between 0 and 1. Then we can directly provide that values to this one. So here you can see some other line to categorical data. See, so this is very interesting one. I will explain in another slide, but keep this part aside for now. Okay, I will explain this part. Why you are using this two categorical? What is the effect of this part? Okay, we have to change the text to numerical value, right? Using encoding. After encoding, we have to convert the encoded values into one hot state. So to perform one hot state or to convert the data into one hot state, we have to use this step. Okay, I will explain in the next slide. Okay, so this is another example. This is one example, right? So this is another example. So instead of using or instead of directly using this encoding, or if your data is not encoded properly, you can use encoder here, and instead of directly using this 255, you can use this standard scalar. Yesterday I explained already. These two are the two concepts. Any doubt? Any doubt in these two programs? I'm not running these programs in the what it is Spider. I just want to explain here because I don't have time. I have to explain too many concepts today and tomorrow. Any doubt here or here? Anyway, we will discuss all these programs in upcoming Saturday. No, right? So now let me explain what is the effect of this part, two categorical. So you can see I already explained this part, right? What is happening here from this part to this part. Okay, here I have class with some names, so I'm not supposed to be go with the names, so I have to convert these names into some numerical values using encoding, right? So this part, this encoding, you can see here fit a transform. We can use this one and we can use this label encoder, and we can directly transform into values like this. Do people have any doubt here? I already explained yesterday, but I just want to repeat this part. So now this is one way, but after getting these values, if you want to train ENN or CNN properly, we have to convert these values to one hot state. One hot state is nothing but we have to use the same labels here, but for each and every class here, this is one class, right? I'm getting somewhere else. So you can see here pen is one class. Okay, we are representing all pens with 0, right? And you can see cup is the another class, and we are representing this cup with 1, and here also we are representing this cup with 1. Okay, any doubt here? Now here, if you consider this data, we have total 4 categories. What are the 4 categories? We have pen here. Let me erase all this nonsense first. Okay, what are the 4 categories? Pen, cup, book, and bottle. Okay, we are representing these 4 categories with 0, 1, 2, and 3. I'm just considering the unique values. Okay, now here we have 4 classes, right? Now we have to take 4 columns like this. So this is the 0th column, 1, 2, 3, 4. So I'm representing this 0, 1, 2, 3. Now I have to place 1, 1. The category is same. For example, here it is 0 category, right? So this pen comes into the 0 category, right? So I have to use 1 here. Okay, it is cup. So I have to place this cup in cups category. What is cups category? 1, right? So here I have to place 1. Okay, book, it is 2. So I have to place this book here. Okay, again cup, I have to place this in 1. Again bottle, I have to place this in 3. Okay, now if you see, I have only 1 in entire row. If you see here, how many numbers are there? How many ones? You see here, only 1, right? In each and every column, I have only 1 or 1 hot state. We call this as hot state. Okay, first we have to convert these labels into this numerical data using encoder. Okay, after this conversion, we have to convert this encoded values into 1 hot state. Okay, so we are doing both the things here. Okay, first we have to encode these values if the values are not encoded. One more thing, here the values are not encoded, so we are using encoder. After that, we have to use this 2 categorical line. Any doubt in these 3 steps? These steps are very important because most of the logics or most of the techniques are in data pre-processing only. We can easily take any network by just adding the layers, but data pre-processing is very important. To pre-process data, we require all these techniques. Okay, in some cases we have to use encoder, in some cases we have to use the scalar. We have different scalars. We usually use standard scalar, and in some other cases we have to go for this 1 hot state. Depending on the data and depending on the parameters, we have to set all these things. Any doubt? Okay, I have 7 more minutes and I have so many slides here. I don't want to go with all these concepts today. Okay, let me stop here. If you have any doubts in ANN or what we can say in this playground, you can ask me. Do people have any doubt here? Okay, I will change the order and I will explain one more slide. Okay, now you people are okay with this 1 hot state encoding and scalar, right? So next one is data augmentation. Actually, this is very important for CNN. Okay, but this is not only related to CNN. We can use this concept in any training process or any network. Okay. In playground, I have explained one concept, right? Overfitting and underfitting, and most of the times this overfitting or particularly underfitting will happen due to lack of data. Means if the data collection is very complex part and number of samples are very low, in that case we can go for this augmentation. Augmentation is nothing but, for example, you can see this dog image here, right? We have only this one image. You can use this image and you can generate some similar ones, and this will help us to identify the same dog or this category in different variations or different variations in terms of brightness, color, what we can say in terms of resolution. So we can change all the values and we can generate different images. So for example, you people are only able to gather 100 number of images of dog. So but training a model with only 100 number of images is very difficult. Okay, for sure it will fall into underfit or overfit, right? So to avoid that part, what we can do, we can apply some transformations and we can generate more number of images. You can see I'm just rotating image here. Here I have converted to grayscale. Here I have, instead of taking the entire image, I'm taking only one part of image, and here I have reduced the or resolution. But you see all these are dogs, right? So instead of having one dog, I can generate multiple images. Okay, I can apply these techniques on all the images which I have, and instead of using 100 images, I can generate some 5,000 images by taking 50 images from one original image or 50 augmented images from one original image, and we can train model. Okay, now we are training model with 5,000 images, even though we have 100 number of images, right? So this is the technique which is known as augmentation, data augmentation particularly. Any doubt here? So here you can see how we can generate different images, what will happen when we rotate, okay, when we blur, when we increase the contrast, when we scale, when we illuminate means increasing the levels, brightness levels, okay, when we change the projections, all the things we can see. And here we can see different options available. We can add padding means we can add some extra values, or we can randomly rotate. Here we have 180 degrees rotation, right? So if you want more images, you can add more number of angles. Instead of 180, you can add 30, 60, 90, or you can take random variations or random angles and you can rotate. You will get more number of images. Rescaling is this one. Instead of taking entire image, you can take one part here and one part like this. So we can use different scaling factors and we can rescale. And flipping means horizontal and vertical flipping. Okay, you can flip along x-axis and along y-axis, right? One more thing is translation. We can move image in x and y directions. Okay, next cropping. Cropping means it's kind of scaling only, but in scaling we can use any value, but cropping also same thing. Again, zooming also same thing, but all this comes into same category but with the minor changes in the code. Okay, darkening and brightening, color modification, like here you can see, right, instead of using RGB, I'm using grayscale image. So darkening, so here you can see I'm increasing the illumination, means it's brightening, right? In the same way I can reduce the brightness levels and I can generate another image. We already discussed in our first week, right? All these things, how to change, how to increase brightness, how to reduce brightness, how to select particular area in the image. We know all this concept. That's why I have explained all those things there to generate augmented data and as well as to understand the image techniques. Okay, any doubt here? Next one, grayscaling is this one, and changing the contrast. So here one more thing, color modification is there, right? So color modification here it is white dog, right? White with some mixed color. So we can change this entire white pixels into black and we can create a black dog. Okay, there first we have to go for data segmentation to identify all the white pixels here, and we can replace with black, and then we can have this black dog. For example, you have a red color car, you can identify the entire red color and we can change it to blue, white, black, and we can design multiple cars in different colors. Okay, as you are training your model with all the color cars, your model can effectively identify all the cars in any color, because you are not training your model with only one color of car, right? You are training it with all the colors, so it will increase the accuracy of your model and it will reduce the overfitting. And changing contrast I already discussed, and adding noise. Okay, adding noise and random erasing or randomly adding points means here you can add a small dot and still you can say, okay, even after adding a small dot, this is the apple. Okay, like that. In that case there may be some issues with on the lens, or there may be some small insects on the apple, still we are able to identify this is apple. So like that, we can use these adding noise or random arranging techniques to train our model in more regressive way. Do people have any doubt in data augmentation? Why it is very important, how we can perform both the things? This is very important to increase the model accuracy and to increase the model knowledge and to and to decrease the overfitting and underfitting issues. Okay, how we are increasing model knowledge is, if you have the images of all the cars in all the colors, you can train your model with all the color cars, right? But we have the images of only one color car, means if you have only red color, if you train your model this is a car, then it can identify only if the car is in red color. Okay, but if you go for this augmentation and you train your model with more number of colors or more number of cars with the different colors, different orientations, different sizes, okay, it will increase its knowledge and it will generalize the knowledge. The term is generalization. From day one I am concentrating on this generalization, right? Generalization is very important. That's why we have to avoid and overfitting. Okay, so by using this augmentation, we can increase the size of data set and we can reduce the all these overfitting and underfitting issues, and we can increase the knowledge. Okay, again, this is very important. If the size of data set is very less, or data collection is very complex part. One more thing, to generate this augmentation data, we require at least very small set of data. Without having these dog images, we can't generate all these things, right? But still now we have some advanced concepts where we can provide some constraints of the image and it will able to generate the image. For example, I want to generate a dog image which is sitting on a car. Okay, if I provide this scenario, these tools can generate a car and on top of it will place a dog and it will generate a combined image with a dog and a car. But still these tools have all these basic images in their backend, but still they can generate combined images. So sorry, we are already crossed the time. Do you have any doubts? You can ask, otherwise Sundara, we can end this session.
Okay, sir.